the previous video from the Khan Academy, you had a chance to take a look at what the difference is in physics between what we call vectors and what we call scalars. So today we will continue that discussion with a little bit on distance and displacement. So take a look at the screen here. A couple of definitions, very important. On the left, we have the definition and a picture explaining what distance is. So we've defined distance in physics as the length of the path from one position to another. On the right-hand side, you'll see we're talking about displacement. So these two terms are very closely related, but they actually mean two completely different things. So the displacement, the definition is it's the length and direction between two positions. The important part of that definition being the word direction there, very important. So take a look at those pictures. On the left you can see I have two letters, so A and B. And A and B are actually in the same spots on the page. If I was walking, let's say this represented a map or something like that, and I was walking from position A to position B, but I had to make a bunch of stops along the way. So I followed this kind of path all the way along and then eventually ended up where I was going to go. That would be a lot further of a distance than if I just walked directly there. And that's kind of what displacement is. So displacement is kind of like the shortest path length between two different spots. That's kind of what it's showing us there. So let's take a look at another example. You'll be doing an activity kind of having to do with maps. There's lots of ways we can look at distance and displacement with maps. So take a look at the bottom. This is just from MapQuest. And all I did was take a look at where Calgary, Lethbridge, and Medicine Hat are on a map. So let's say I decided I was going to start off here in Medicine Hat, and I was going to drive up to Calgary, and then back down to Lethbridge. And I was going to do that all in one day. So you can see on the bottom left, this is telling me it would be 516 kilometers. That's a pretty far ways. That would take me, 4 or 5 hours, or 5 hours and 19 minutes, it says here. So that would be the distance. If I started in Medicine Hat and I ended up in Lethbridge, the distance I went would be that 516 kilometers. So it's a pretty long ways. Displacement, however, is, remember the difference between where I started in Medicine Hat and where I finished down here in Lethbridge, which is actually a much shorter distance. So if I measured it using the scale that they give me here, down here in the bottom left, that's actually 147 kilometers. So I can say the distance from Medicine Hat to Lethbridge going through Calgary would be 516 kilometers. The displacement, however, is only 147. So you see, I get a displacement that is much smaller than the distance. The other important thing you'll see in my displacement is also these kind of letters after, which are telling me the direction. So it ends up being south of west. So again, that idea that displacement has to have that direction on it. So 147 kilometers south of west. So let's take a look at another example using a map. At the top of this page, you will see a formula that will allow me to calculate for a change in distance. So here I see a triangle, a change in distance, up there at the top. That triangle or delta notation just means a change in distance is distance 1 plus distance 2 plus distance 3. At the end of that, I see this dot, 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 meaning that number could keep going. I can keep going. I could have 4 distances, 5, 6, 7. It doesn't really matter. I'm just going to add them all up. So take a look at the question at the bottom here. It says calculate the change in distance if you walked from Hat High to Swirls. So if I'm using my map here, I can circle where Hat High is. I see it's right about there. I can take a look where Swirls is. It's up there. I also see on this map it's telling me that a block up and down, or a north-south block, is 50 meters, whereas an east-west block is 100. So those two numbers are going to help me with my calculation. So if I want to solve this question, the first thing I'm going to do is write down a formula. So whenever we do physics, we always want to work with a 3-step process. So my first is always going to be writing down my formula. So in this case, I can say change in distance will be distance 1 plus distance 2 plus distance 3. I'm kind of running out of room there, so that'll be kind of squished in there, but that should say distance 1 plus distance 2 plus distance 3. From there, all I'm going to do is plug in each of my numbers. So using the map, I know distance 1 is 50. So right here, I've gone 50 meters up. Then I went 100 meters over and another 100 meters over. So if I want to put that into my equation, over here I can say, well, I started with 50 meters. Then I added to that 100 meters. And added to that another 100 meters. So these are all just approximate values. So far there's 2 of my 3 steps. I have a formula, I have an equation, and now I need an answer. So I know 50 plus 100 is 150, add another 100, gives me 250 meters. Since this is distance, and distance is a scalar quantity, I don't need to put a direction on the end of that, and I'm done. All right, let's do some more examples. Okay, so let's do a couple other practice problems. This time we will try one that has to do with displacement. So take a look at that picture. As you are going through these examples, please write this down. So this question asks me to find the displacement from the bus stop to the bench. So if I take a look here, I know that this bus stop is in the middle at 8 meters east of the home. Then I have the bench way over here at 18 meters east. So I know I mentioned this before, but really important, I want to stress this. Make sure you are doing your 3 steps every single time. So I'm always starting with a formula, then plugging in my values, and then calculating my final answer. So at the bottom here, we're going to solve this problem together. I'll show you how I kind of want it done, and then give you some time in this video to do some on your own. So first thing I'm going to do is write down the formula. So I can say, well, change in displacement is going to be distance 2 minus distance 1. So I'm always going to use this formula for displacement questions. The other thing, it's kind of hard to see up top, but all of those D's have little arrows on top of them. So right up here. And the reason those arrows are there is because displacement is a vector quantity. Because it's a vector, we show this in our formulas by putting the arrows over top. So I can say the change in displacement, there's my formula, is d2 minus d1. Second step, I'll plug in my values. So my second one, or my distance 2, way over here, is 18 meters, minus my original, or my first distance or position, is 8.0 meters. So this one, 18 minus 8, I know gives me 10 meters. So there's my magnitude, or my amount. I know that the change in displacement is 10 meters, but then I need to put a direction. So the displacement from the bus stop to the bench, if I look at that arrow, it's going east. So at the end of my answer here, I need to add in the word east. So now I have a magnitude, 10 meters, and a direction, east. So I'm done. That would be full 3 marks. So at this point, I'd like you to pause the video, read through that question, and give it a try. When you're done, press play, and I will provide you with the solution. Okay, so hopefully that gave you enough time. You paused the video. Really important that you're trying these practice problems on your own before watching the solutions. You don't want to just watch me do it. You won't get as much out of that. So if you haven't already, pause it, try this on your own, and then I'll do it for you. So this question says, find the displacement from the tree to the rock. So again, I can say change in displacement is d2 minus d1. I can put arrows on top. If I don't want to put the arrows, a line will work as well. That's fine. So this says from the tree to the rock. So my tree is my D1, my rock is my D2, because I'm going from the tree to the rock. So D2 is always where I end, D1 is where I start. So my distance 2 is the rock, it's 21 meters, minus my D1, the tree, 14 meters. So I can say 21 minus 14 is 7 meters. Because this is displacement, I need a direction on the end. I can say this is going east. So now I would get a full 3 marks. If this question was for marks, I would get all 3. I have a formula, I have my work shown, and then I have a final answer with a direction. Okay, another important thing I want to talk about here is when we're doing some of these questions, in physics we can also use positive and negative signs to tell us the direction, and that's what this chart is showing you at the bottom. Take a look at this guy in the middle. Imagine this is you and you're walking, and I want to describe in words or mathematically how you're walking. If you're to walk forwards, we can say you're walking in a positive direction. Whereas if you were to walk backwards, another way we can word that or use signs is by saying that's a negative direction. So we're using positive and negative signs to tell what direction you're going. So take a look at the bottom, some other common ways you can see these. For positive can also mean east, so it could also mean north. Remember, east would be like this, north would be like this, right or up. So anything that's going kind of to the right or up, east, north, we describe those as positive values. Negative ones, just the opposite. So anything going west, something going south, left, or down. Oftentimes in physics, those will be our negative. So it's kind of hard to wrap your mind around, but we use positives and negatives to tell us the directions. So let's try one of these. Hopefully here to kind of incorporate some positives and negatives. So the first one says, find the displacement from the volcano to the treasure. So volcano is where I'm starting, to the treasure, way over here. So this wants the displacement from displace 1 or D1 all the way over here to D2. So if I'm calculating this displacement, I'll always start off with the same formula. It's equal to D2 minus D1. Please make sure you are writing this down. So find the displacement from the volcano to the treasure. D2 minus D1. My volcano is my D1, my treasure D2. So I'm going to start off with D2. So my treasure is at 2.5 kilometers. Minus my D1, which is 34 kilometers. So there's my equation. 2.5 kilometers minus 34 kilometers gives me a negative 31.5 kilometers. So this is where that negative we were just talking about becomes important. I have a couple options. I could leave this, my answer like this, negative 31.5 kilometers, or an even better way to write that would be 31.5 kilometers. And then I need to figure out, well, what does that negative really mean? If I look at the picture, it means that I started here at my volcano. I went to the left to the treasure chest, or rather than left, a better way of describing that would be west. So in this case, that negative sign actually just means that we're going west. So pause the video here, try that second example on your own. Displacement from the tree to the treasure. Okay, back to this one. Displacement from the tree to the treasure. Again, we're starting with our same steps. D2 minus D1. Hopefully you're starting to get the hang of this. This second one, I'm going from the tree to the treasure. So that means I'm ending at the treasure at 2.5. So that's my D2, 2.5 kilometers. I started at the tree, 14.5 kilometers. If I take 2.5 and I subtract 14.5, that's going to give me an answer of negative 12 kilometers. Again, like we just talked about, I could leave that as negative 12, or I could rewrite it as 12 kilometers. And we know negative means west. Another way of writing directions is like this, a capital letter inside of a square bracket. So I could use a capital W for west, a capital E for east, you know, so on and so forth. Okay, I'm going to give you a couple other examples that we will take up in class tomorrow. So here's the first one. Once you have this on your screen, write down the question, pause the video, and then finish your answer. Tomorrow when we go through this in class, I want to see your 3-step equations. So always a formula, always showing me your work, followed by your response. So that's your first question. And then I want you to try this one. So again, once this video is on your screen, as I'm talking here, you can be writing that question down and then doing your solution. So this is the end of the video. You may need to rewind it to pause those questions on your screen, solve those 2 questions, bring them to class tomorrow. Thank you.